All right, welcome to The Explainer. Today, we're going to break down a research paper that just might have cracked one of the biggest problems in AI video generation. I mean, we've all seen these incredible AI-generated clips, right? They can create these stunning worlds. Some look totally real, others are like a painting, and some are just completely out there. The creativity, the detail, it's just mind-blowing. But have you ever noticed that? They're always so short. Just when you're getting into it, poof, it's over. So why is that? Well, it's not because the AI runs out of ideas. The reason is actually way more technical and kind of fascinating. So let's get into it. The big problem here isn't about creativity. It's a hard physical limit, a hardware problem that's basically kept AI video stuck in these tiny few-second loops. If we ever want to get from seconds to minutes of video, we have to solve this huge memory problem. Okay, think about it like this. For a video to make any sense, it has to be consistent, right? A character needs to look like the same person from frame to frame. To do that, the AI has to constantly remember what it just created. It's looking at the past frames to figure out what the next one should look like. And this is where we hit the wall. Because that memory, it fills up. And it fills up insanely fast. This is the big bad, the villain of our story today. It's a system-breaking issue that has held back AI video for years. All right, section 2, let's meet this memory hog. Now, it has a fancy technical name, but let's just call it the AI's short-term memory for now. This right here, this is the bottleneck. The official term is the KV cache. The best way to think of it is like a scratch pad. As the AI generates a video, it's constantly jotting down notes about what's happening, the characters, the background, everything. And of course, the longer the video gets, the more notes it has to write down. Now here's the crazy part. The AI model itself, the brain of the operation, that's a fixed size. It doesn't change. But this KV cache, this scratch pad, it just keeps growing with every single frame. It balloons in size until it's just completely out of control. Just how big are we talking? Get this. To generate just 5 seconds of a pretty standard video, you can need 34 gigabytes of memory just for this cache. That's huge. In a lot of cases, that's more memory than the entire AI model itself. And that's the bottom line. It's more memory than a top-of-the-line consumer graphics card, like an RTX 4090 even has. The system literally just runs out of space. The GPU throws its hands up, and the whole thing crashes. This has been the brick wall for AI video creators. And look, this isn't just some nerdy efficiency problem. It's a creativity problem. When the memory is this limited, the AI starts to forget things. A character's shirt might change color. Objects can just vanish. The whole scene falls apart. You can't tell a coherent story if your narrator has amnesia. So, how do you get past that brick wall? Well, this is where it gets really clever. The researchers behind this paper found an insight, a kind of secret weakness that's hiding in plain sight in every single video. And what's that secret? Massive redundancy. Think about it. In any video, a huge amount of the information is just repeated. That blue sky, it's the same blue for hundreds of frames. The background behind a talking head, it doesn't change. So the AI is wasting a ton of memory, basically writing down sky is blue, sky is blue, sky is still blue, over and over again. And that was the big aha moment. What if the AI didn't have to write down everything? What if instead it could come up with a really efficient shorthand? Okay, so this brings us to the actual solution. It's a clever compression trick called Quant VideoGen, or QVG for short, and its entire job is to tackle that memory-hogging KV cache. The plan is actually pretty simple, but it's super powerful. QVG has a 2-step plan. First, it looks at all the data and groups together all the similar repetitive stuff. Then, and this is the key, it only bothers to remember the differences, the small changes from one frame to the next. Okay, take a look at this. This is what the raw data in that KV cache looks like. It's a mess, right? All noisy and scattered. This is the inefficient version that's eating up all our memory. And now, look at this. This is the data after QVG works its magic. See how it's all smoothed out and organized? It's taken all that redundant noise and simplified it, leaving just a clean, compact signal. I mean, the difference is just night and day. But it doesn't stop there. There's a second step that makes this shorthand even more precise. Think of it like this. It takes a couple more passes at the data, each time getting a little more detailed, making sure that no important stuff gets lost during the compression. So, the big question, does all this smart compression stuff actually work? Let me tell you, the results are, well, they're not just a little better, they're a total game changer. Okay, so remember that insane 34 gigabyte memory footprint for just a 5-second video? With QVG, that gets slashed down to just 5 gigabytes. That's a reduction of almost 7 times. It's a huge deal. And here's the kicker, it's not just about saving space. Look at these numbers. QVG saves a little more memory than the old way, sure, but check out the quality score. It's way higher. So how is that possible? How do you use less memory and get a better video? Well, by getting rid of all that redundant noise, the AI can focus its brain power on the details that actually matter. It's the definition of a win-win. So, what does this actually mean for people? It's huge. The researchers point out that for the first time, you can run a powerful video model on a single RTX 4090. This takes long video generation out of the hands of giant tech companies with massive data centers and puts it right onto the desktops of creators everywhere. It's a massive leap for accessibility. So when memory isn't the roadblock anymore, what happens next? What kinds of worlds are we going to create? We're talking about unlocking the potential for everything from minute-long animated shorts to fully interactive, endlessly generating worlds. That barrier, the one that kept AI videos stuck in those tiny little loops, it's finally been broken.